Hey y'all, today we're talking about one-step equations, but with rational numbers. So remember, rational numbers include decimals and fractions. So we're gonna follow the same steps. We're gonna find the solution by using inverse operations to isolate the variable, and then we can always check our work to make sure that our answer is correct. So you're probably gonna want a calculator for this. So go ahead and get that out, and let's get started. Let's look right here at number 1. We have negative 6.12 equals 3.4 m. So my variable is that m right there, and I want to get it by itself. How is it connected to 3.4? Well, it's connected through multiplication. So how do I undo that multiplication? I divide. And remember, whenever you're working with equations, whatever you do on one side, you must do on the other. So I like to draw that line through my equal sign. So we've already established that we are going to divide by 3.4 on both sides of the equal sign. And like I said, this is where you want your calculator. We're going to put in our calculator negative 6.12 divided by 3.4. And I actually have my calculator pulled up right here. So negative 6.12 divided by 3.4, and we get negative 1.8. So I'm going to go back to my notes. So we know that negative 1.8 equals m. Now, we can always check our work, and we check our work by plugging in negative 1.8 for m. So it would look like this. Negative 6.12 equals 3.4 times negative 1.8. And I want to make sure that 3.4 times negative 1.8 is going to be negative 6.12. So I'm going to go back to my calculator. So we have 3.4 times negative 1.8. And I get negative 6.12. So back to our notes. We know then that negative 6.12 equals negative 6.12. I have the same thing on both sides, so I know that my answer is correct. Let's move on to number 2. We're still working with decimals here. A plus 12.75 equals negative 6.1. So our variable is this a, and we're trying to get it by itself. So how is it connected to the 12.75? Well, we're adding 12.75 to a. So how do I undo that? Well, if you said subtraction, you're right. And remember, whatever I do on one side, I want to do on the other. So I'm going to end up subtracting 12.75 on both sides of my equal sign. Now on the side with the a, 12.75 minus 12.75, that cancels out, and I'm left with a by itself, which is exactly what I want. But on the other side, I have negative 6.1 minus 12.75, and you could work that out on paper, or you can use your calculator. So we're going to go to our calculator. We have negative 6.1 minus 12.75, and we get negative 18.85. So go back to our notes. Negative 18.85 is our solution. So what do we want to do once we have our solution? We want to check it. We want to plug it back in and make sure it is the correct answer. So where I see A, I'm going to plug in negative 18.85. So negative 18.85 plus 12.75 equals negative 6.1. And I just want to verify that when I add those two numbers right there, I get negative 6.1. So let's go back to our calculator and double check. So we have negative 18.85 plus 12.75, and I do indeed get negative 6.1. So back to our notes, we know that negative 6.1 is what I have on the left-hand side, and that equals the negative 6.1 that I have on the right-hand side. It's the same number on both sides, so I know my answer is correct. Okay, moving on to number 3. So this time we have fractions. So we're still trying to get our variable by itself, and we still know that whatever we do on one side, we must do on the other. So our variable is this m right here. How is negative 3 over 2 connected to m? If you said it's connected through multiplication, you're correct. So how do I divide? Well, remember, when you're dividing with fractions, you multiply by the reciprocal. So I'm actually going to take this fraction right here and flip it upside down. That means the 2 moves to the top and the 3 moves to the bottom. That's the reciprocal. So to divide by that fraction, I'm multiplying by negative 2 over 3. And why does that work? Well, my 3's would cancel out, and so would my 2's. So I would be left with just m. So m is by itself. But remember, because I multiplied by negative 2 over 3 on the left-hand side, I want to do the same thing on the right-hand side. Now, does anything here reduce? 15 over 16 times negative 2 over 3. Remember, to look to see if anything reduces, we're looking diagonally. So what about 15 and 3? Well, 3 goes into 15, right? So my 3 can become a 1, and 3 goes into 15 5 times. What about the other direction? Does 2 go into 16? 2 does go into 16, so that 2 becomes a 1, and 2 goes into 16 8 times. So now when I multiply across, 5 times negative 1 is negative 5, and 8 times 1 is 8. So negative 5/8 is my answer. And you could have done that with a calculator too, but we knew how to do it on paper on our own. So let's check our work. How do we check our work? Well, we plug in negative 5/8 for m. So we've got negative 3 over 2 times negative 5 over 8 equals 15 over 16. And we could take this to our calculator, but we can also check it here. So negative 3 times negative 5, is that 15? It sure is. Negative 3 times negative 5 is 15. And 2 times 8, is that 16? It is. So I know that my answer is correct. And just to show you, we can put that into our Desmos calculator. So we have negative 3 over 2 times negative 5 over 8. And it gives me that decimal, 0.9375. But if I hit that button right there, it just makes it a fraction. So 15 over 16 is exactly what we were looking for. Okay, let's look at number 4. So we have negative 2/3 plus y equals negative 2 1/6. So the first thing I want to do when I see this problem is I want to change this mixed number to an improper fraction. So remember to do that. We're going to multiply. 6 times 2 is 12, plus 1 is 13. So I'm just going to rewrite this. Off to the side over here, we have negative 2 over 3 plus y equals, and we said it was negative 13 over 6. Okay, so that helps me. Now, one thing I also want to do is I want to try to get to a common denominator. So 3 and 6. Which one can I change? If you said this one right here, you're correct. So I know to get from 3 to 6, I would just need to multiply by 2 on the top and bottom. So that's going to become negative 4 over 6. So So again, I'm just rewriting it. We have negative 4 over 6 plus y equals negative 13 over 6. So now both of my fractions have the exact same denominator. So I think it's going to be a little bit easier for me to solve this one. So whatever I do on one side, I want to do on the other. And I want to get this y by itself. So I need to get rid of the negative 4 over 6. How do I do that? Well, because it's negative, could I just add 4 over 6? Would that cancel it out? It would. So I need to do the same thing over here, plus 4 over 6. So on the side with the y, that fraction cancels out, and y is left by itself, which is exactly what we want. But on the other side, I have negative 13 over 6 plus 4 over 6. And remember, because we already got to the same denominator, I really just need to focus right now on my numerators. So I have negative 13 plus 4. Well, I'm adding integers that have different signs, so I'm going to subtract. 13 minus 4 is 9, and I keep the sign of the bigger number, so it's going to be negative. So I have negative 9. Don't forget to put it over 6. So negative 9 over 6 is my answer. And I could reduce that. You know that 3 goes into both of those. So negative 3 over 2 would be a perfectly acceptable answer, but we'll actually just go ahead and write that. Okay, so now we need to check our work. Remember to check our work, plug it back in. So, change our color back, and I'm going to work over here on the left-hand side. So we have negative 2 over 3, plus I'm plugging in negative 3 over 2, equals, we're going to go with negative 13 over 6. Okay, so I could change all of my fractions, and that's what I'm going to do because I think I can do this in my head. So I know to go from 3 to 6, I'm just multiplying by 2 on the top and bottom. So that becomes negative 4 over 6. To go from 2 to 6, I'm multiplying by 3, so times 3 on the top and bottom. So plus negative 9 over 6 equals negative 13 over 6. Okay, so now because everything has the same denominator, I'm just focused on my numerators. So negative 4 plus negative 9. Well, they're two negative numbers, so I'm going to add them together and keep it negative. Negative 4 plus negative 9 is indeed negative 13. So I have negative 13 over 6 equals negative 13 over 6. The same thing on both sides, so I know my answer is correct. Okay. Moving on to our last one, and you'll have one just like this on your basic skills quiz coming up. So pay close attention. Okay, remember, whatever we do on one side, we must do on the other. And our objective is to get this a by itself. How is a connected to 9 over 8? It's connected through multiplication, so I would normally divide. But I'm not going to divide because it's a fraction. And when I divide with a fraction, I really multiply with the reciprocal. So I'm going to multiply with a fraction, but I'm just going to flip it upside down. So the 8 goes to the top, the 9 goes to the bottom. So I'm multiplying by 8 over 9. And I'm going to do that on both sides. So on the side with the a, the 9's cancel out, the 8's cancel out, and I'm left with a by itself. Now on the other side, I've got negative 2 times 8 over 9. Could I write it so I have two fractions? I sure could. And I can't reduce anything, so I'm just going to multiply across. So multiply the numerators together. Negative 2 times 8 is negative 16. And then multiply the denominators together. 1 times 9 is 9. So negative 16 over 9 is my answer. And I'm just going to leave it as that improper fraction that doesn't reduce. Now I need to check my answer, and I check it by plugging it back in. So we have 9 over 8 times negative 16 over 9 equals negative 2. Now we want to see if anything reduces. So let's look diagonally. 9 and 9, that's the same number. So those both become 1, right? That's a 1, that's 1. What about the other direction? 8 and negative 16. Does 8 go into 16? It sure does. 8 goes into 16 2 times, so that 8 becomes a 1. So now when I multiply across my numerators, 1 times negative 2 is negative 2. And then 1 times 1 is 1. I don't need to write it negative 2 over 1 because that's just negative 2. So I have the same thing on both sides. My answer is correct. So that is the end of our review on one-step equations with rational numbers. Y'all have a great day.